Okay, start. Hello, everyone. Today I'm going to present our research title Fault of Our Stars Behavioral Drivers of Rating Sentiment Incongruence. This work was carried out by our team from the Department of Computer Science and Engineering at the University of Merton. So, the main question behind our research is quite simple. Can we really assume that a star rating accurately represents the sentiment expressed in a written review? And our findings suggest that the answer is not always. So, when people write online reviews, they usually communicate their experience in two ways. First, they give a star rating, such as 1 to 5 stars. Second, they write a textual review, explaining their experience. In many sentiment analysis studies, these star ratings are used as convenient labels for the sentiment of the review text. But there is an important assumption here. A 5-star review is assumed to be positive, a 1-star review negative, and so on. However, consider a review saying, the gardens were beautiful, but the place was overpriced and overcrowded. A person could give this review 5 stars, even though the text itself contains criticism and mixed sentiment. So, the rating and the text are not necessarily saying exactly the same thing. This creates a problem when we use ratings as ground truth sentiment labels. If the labels are noisy or biased, models trained using those labels may learn the wrong patterns. Our research therefore investigates this rating sentiment incongruence. Moving on to the research gap and objectives, previous research has already shown that rating and textual sentiment can sometimes disagree. However, there are still several gaps. Much of the existing tourism sentiment research focuses on hotels and restaurants, while tourism attractions have received less attention. Also, previous studies have often focused simply on whether a review is matched or mismatched. We wanted to go further. Our objectives were first to measure how frequently rating and textual sentiment disagree. Second, to identify different types of mismatches rather than treating all mismatches as the same. Third, to investigate whether factors such as venue type, reviewer experience, reviewer length, and time are associated with incongruence. And finally, to understand what these findings mean for using star ratings as sentiment labels in natural language processing. The dataset. For our study, we use the Tourism and Travel Reviews Sri Lankan Destinations dataset. It contains 16,156 English language reviews collected between 2010 and 2023. The reviews cover 11 different types of tourism attractions in Sri Lanka. We grouped the star ratings into three classes. 1 and 2 stars were considered negative, 3 stars were neutral, and 4 and 5 stars were positive. We then independently predicted the sentiment of the written review text using transformer based NLP models. This independence is important because we did not use a star rating to determine the textual sentiment. The methodology. Our methodology consisted of several main stages. First, we cleaned the dataset and engineered features such as review length, review delay, travel year, location, and reviewer contribution count. Next, we needed to select an appropriate sentiment model. So we manually labeled 1,000 reviews and divided them into 700 training and 300 testing instances. We evaluated four transformer-based models using accuracy, macro F1, and weighted F1. The pre-trained Twitter Roberta sentiment model achieved the best overall performance with an accuracy of 0.830 and macro F1 of 0.692. So we selected it to classify the complete dataset. After predicting the sentiment for all the reviews, we compared the predicted textual sentiment with the rating derived sentiment. Whenever they differed, we classified the review as incongruent. Finally, we used statistical tests, logistic regression, random forest, and sharp analysis to investigate the potential drivers of incongruence. The six incongruence patterns. One of the main contributions of our research is that we did not simply say whether a review was matched or mismatched. Instead, we identified six directional patterns. These include conservative rater, obligatory 5 star, frustrated neutral, polite inflator, harsh deflator, and punitive rater. The most common pattern was the conservative rater, representing 38.4% of all incongruent reviews. The second was the obligatory 5 star, representing 28.3%. Together, these two patterns account for 66.7% of all mismatched reviews. Well, this is important because it tells us that the mismatches are not simply random errors, but these are recurring errors, recurring behavioral patterns in how people assign ratings compared with how they express themselves in text. Now we come to our most important finding. Out of the 16,156 reviews, 3,005 were identified as incongruent. This gives an overall incongruence rate of 18.6%. In other words, approximately one in every five reviews had a mismatch between its star rating and the sentiment expressed in its text. This is a significant finding because ratings are commonly used as weak labels in sentiment analysis datasets. If almost one in five labels doesn't agree with the textual sentiment, then blindly treating ratings as ground truth can introduce systematic label noise. And because the mismatches follow identifiable patterns, this noise does not appear to be completely random. We also found that incongruence varies depending on the projection. Museums had the highest incongruence rate at 26.3%, while national parks had the lowest at 12.8%. The association between venue type and incongruence was statistically significant. This suggests that ratings may not be equally reliable across different tourism contexts. For example, a museum visit can involve several different aspects: exhibits, heritage value, crowding, pricing, accessibility, and facilities. A single star rating may not capture all of these dimensions. We also found an important reviewer effect. Expert reviewers were approximately 1.97 times more likely than novice reviewers to produce incongruent reviews. Interestingly, the conservative rater pattern increased from 27.4% among novice reviewers to 40.4% among experts. This suggests that experienced reviewers may use ratings differently from less experienced reviewers. So, to investigate the drivers of incongruence further, we used both linear and nonlinear models. Our logistic regression model achieved a test AUC of 0.584. The random forest performed slightly better, achieving an AUC of 0.6095. The improvement is modest, but it suggests that some nonlinear relationships exist. More importantly, the models helped us understand the factors associated with incongruence. Our analysis highlighted variables such as reviewer expertise, review length, venue type, travel year, and review delay. Sharp analysis was then used as a post hoc interpretation method for the random forest. One interesting temporal finding was that incongruence showed a modest decline over time. The results suggest that more recent reviews tend to have somewhat better alignment between their textual sentiment and ratings. So, what do these results actually tell us? The most important point is that ratings and textual sentiment are not interchangeable signals. A rating may represent someone's overall judgment, while a written review can contain so much more detailed, mixed, or context dependent information. Therefore, when researchers automatically convert ratings into sentiment labels, they may introduce systematic bias into their datasets. Our findings also suggest that label reliability is context dependent. The reliability of rating can vary according to the attraction type and the behavior of the reviewer. At the same time, we should be careful about interpreting our results. Our sentiment model was pre trained on Twitter style data rather than tourism reviews. Manual evaluation consisted of 1,000 reviews, and we did not manually validate the full set of incongruent reviews. Therefore, some detected mismatches could potentially be caused by sentiment model errors rather than genuine reviewer behavior. These are important limitations and directions of our future work. To conclude, our study found that 18.6% of Sri Lankan tourism reviews show ratings enabling incongruence. We identify six distinct mismatch patterns with conservative rater and obligatory 5 star accounting for the majority of mismatches. We also found that review expertise, review length, venue type, and temporal factors are associated with this phenomenon. The broader implication is important for NLP research. Star ratings should not automatically be treated as ground truth sentiment labels without validation. If ratings and text capture different aspects of a user experience, then using ratings as labels can introduce systemic noise into sentiment analysis models. Therefore, future sentiment analysis pipelines should consider the reliability of weak labels before using them for training or evaluation. Thank you. Okay, stop.